If you wish to top in exams, you've tuned in to the right show. Yes, the show is all about helping you gain that extra edge over all the others. Hello, I'm Arjun Bhagat. Nice to see you once again at Toppers Exam Special. Well, working hard is a thing of the past. The present is all about working smart. That's why we at Topper don't just study hard but also study smart. Well, enough said. Let's see what we are going to look at in our first segment, Trend Spotting.
In today's episode, we will talk about haloalkanes, haloarenes, alcohol, phenols, and ethers. The chapter Haloalkanes and Haloarenes carries a total weightage of 4 marks. And the second chapter, Alcohols, Phenols, and Ethers, worth 4 marks. So out of the total 70 marks, the relevance of both the chapters is about 6%. Now, pay attention to your television screens to know about the type of questions that are generally asked in the board exams from these chapters. Looking at the trends, you can typically expect very short answer type questions worth 1 mark or short answer type questions worth 2 or 3 marks.
Having seen the trends, why don't we have a look at the important topics from these chapters that you must have on your fingertips? Yes, you guessed it right. It's time for the recap.
From the chapter Haloalkanes and Haloarenes, you should be clear with the nature of the carbon-halogen bond, methods of preparation of haloalkanes as well as haloarenes, physical properties of haloalkanes and haloarenes, reactions of haloalkanes with a special focus on nucleophilic substitution reaction and elimination reaction, and reactions of haloarenes. Whereas from the chapter Alcohols, Phenols and Ethers, you should remember all about classification and nomenclature of alcohols, structure of alcohols, phenols and ethers, preparation and properties of alcohols, phenols and ethers, and acidity of alcohols and phenols.
It is very important for us to be well versed with all the topics that we just told you about in the recap segment. Now, before we start practicing questions, let me tell you about the type of abilities that you'll be tested on in the exams through these chapters.
In today's episode, we will talk about haloalkanes and haloarenes, alcohol, phenols and ethers. You will generally be asked conceptual questions. However, representative problems can also be asked based on nomenclature, mechanisms and name reactions.
You know what could be the perfect complement after all that we have done till now? What else but a model question? And this is not just any question, it is actually a window of what you can expect from the examiner. So the first step to that perfect score could very well be this question.
In the model question, we have been told that a compound A with molecular formula C4H10O on oxidation forms compound B. The compound B gives positive iodoform test. Compound B on reaction with CH3MgBr followed by hydrolysis gives C. So you need to identify A, B and C. This problem is worth 3 marks and is conceptual in nature. It is rated as difficult on the judgment meter. So to answer it, we will begin with the molecular formula of A, which is C4H10O. This means that the compound is an alcohol with 4 carbons. A on oxidation gives B, which means that B is an aldehyde or a ketone. Next step is to find the position of the functional group. It is given in the question that B gives a positive iodoform test. We know that iodoform test is given by those aldehydes and ketones which have CH3CO group. Therefore, the carbonyl group is present on the second carbon. Thus, the compound A is butane 2-ol and the compound B butane 2-one. For identifying the compound C, it is given in the question that B on reaction with Grignard's reagent methyl magnesium bromide followed by hydrolysis will give C. We know that B is a ketone and ketones, when reacted with Grignard's reagent followed by hydrolysis, forms a tertiary alcohol. Thus, the compound C is 2-methyl-butane-2-ol. Identifying the structure and name of A, B and C will fetch you 3 marks. The sequence of the reactions is given on the screen.
I know it was a tough one, but don't worry, practice enough of such problems and exams will become like a cakewalk for you. And since we are talking about questions, let's proceed to our first set of practice problems. Remember always, practice makes perfect.
So in question number 1, you are supposed to write the reactions and the conditions involved in the conversion of 1. Propene to 1-propanol, 2. Phenol to salicylic acid. This is a 2 marks conceptual question. It is rated as average on the judgment meter. Okay, for answering the first part, propene is an alkene and it can be converted to alcohol by acid-catalyzed hydration and hydroboration oxidation. The method can be chosen depending on the product. If we choose acid-catalyzed hydration method, the product will be propane-to-ol. And if we choose hydroboration oxidation method, the product formed will be propane-1-ol. So we will choose hydroboration oxidation method. In this method, propene is reacted with diborane to form trialkyl boranes as addition product. This on reacting further with hydrogen peroxide in the presence of aqueous sodium hydroxide to give propane-1-ol. As you write this conversion correctly, you'll be awarded 1 mark. And for answering the second part, you need to know that salicylic acid is 2-hydroxybenzoic acid. For conversion of phenol to salicylic acid, phenol is first reacted with sodium hydroxide, followed by reaction with carbon dioxide to give salicylic acid. This part is also worth 1 mark and thus you score full 2 marks for writing correct reactions. And always remember that phenols undergo electrophilic substitution reactions on the benzene ring. Just be sure to check both the reactant side and the product side of the reactions, as this is imperative to get the perfect score. One mistake could make all the difference.
It's time for a break now, but don't go anywhere because I'm going to be back soon with a lot more. There are more practice questions, the HOTS problem and all those priceless exam tips waiting just for you. You can also log on to our website www.topperlearning.com for any kind of extra help that you need in relation to the exams. But how can I leave you without the breaking question of the day? Here it goes.
Well, you have to arrange bromobenzene, chlorobenzene and iodobenzene in the order of increasing boiling points. Before the break, I had left you with a question, where you were required to arrange bromobenzene, chlorobenzene, iodobenzene in order of their increasing boiling points. So the answer for the first set is, the boiling point increases with the increase in molecular mass. Therefore, chlorobenzene will have the least boiling point, bromobenzene will have higher boiling point than chlorobenzene, and lastly, iodobenzene will have the highest boiling point.
Welcome back to Toppers Exam Special. I'm Arjun. I hope you comprehended the solution to the breaking question well. So before the break, we did a model question related to chemical properties of alcohols and also solved practice questions. Now let's move on to another practice question that is based on conceptual ability.
You need to tell which compound in each of the pairs will react faster in SN2 reaction and why. Your choices are 1. Methyl bromide or methyl iodide, CH3Br or CH3I. 2. CH3 CCl or CH3Cl. This problem featured in the 2008 examination and is worth 2 marks. It is an average one as per our difficulty meter. For answering this question, you should keep in mind the mechanisms of SN1 and SN2 reactions. Let's see the solution now. 1. Methyl iodide will undergo SN2 reaction faster because of its low bond dissociation enthalpy of Ci bond, and iodide is a better leaving group than bromide. Iodide will be released at a faster rate in the presence of an incoming nucleophile. Now for part 2, you must mention that methyl chloride will undergo SN2 reaction faster because primary alkyl halides react faster in SN2 mechanism than tertiary alkyl halides. This is because of less steric hindrance in primary alkyl halides than in tertiary. You need to keep in mind that SN1 mechanism proceeds via a carbocation and SN2 mechanism proceeds via the formation of a 5-membered intermediate.
Before we proceed to the next question, let me tell you that it's very important to pay attention while reading the question as well, just like while attempting the answer. Sometimes the question may not be as direct as you first thought, and that could reduce your score. With this tip, let's move on to our next practice question.
Here you have been asked to explain how a hydroxyl group attached to a carbon in benzene ring activates benzene towards electrophilic substitution reaction. This question, like most others, is a conceptual one. It involves the application of the knowledge gained while studying the various reactions of the chapter and is worth 2 marks. Topper's judgment rates it as an average one. So in the answer, we'll say that the hydroxyl group is a highly activating group. It directs the incoming electrophilic groups to ortho and para positions in the ring. This is because these positions become electron-rich due to the resonance and inductive effects as shown in this graphic. Always keep your eyes open while attempting questions related to resonance in the benzene ring and practice the structures by drawing them on paper so that you know where to draw the single and the double bond.
So we have solved 3 practice questions. Let's not waste time and tackle the last one. That is the 4th practice question, and this one will help you move closer to perfection.
Here you need to tell that why 1. Phenols are much more acidic than alcohols. 2. The boiling points of ethers are much lower than those of the alcohols of comparable molar mass. This is once again a conceptual question. Actually, most questions that feature in the examination from this topic are conceptual. And to stress on the importance of this problem, it's vital to tell you that it was asked in the CBSE 2007 paper for 2 marks. For attempting such problems, you need to recall the specific properties and the reason for the properties. Once you recall it, then write that the alcohols on losing H+ ion form an alkoxide ion, whereas the phenols form phenoxide ions on losing H+. The phenoxide ion is more stable than alkoxide ion due to resonance. Therefore, phenols are more acidic than alcohols. This step is worth 1 mark. After this, you should specify that The boiling points of ethers are much lower than those of the alcohols of comparable molar masses because, unlike alcohols, ethers cannot form intermolecular hydrogen bonds. Write this step correctly to get the second mark as well. You also have to remember that the properties of alcohols and phenols are chiefly due to the hydroxyl group. The nature of alkyl and aryl group simply modify these properties.
Well, here the practice session ends for the day, and it is time for us to move on to the hot segment. HOTS problems have been introduced by the CBSE to test your high-order thinking skills. So get ready to use your brains and see what this question is all about.
So you need to give reasons for 1. Why Grignard reagent should be prepared under anhydrous conditions. 2. And why neopentyl bromide undergoes nucleophilic substitution reactions very slowly. This question demands an in-depth knowledge of the concepts of the chapter. Each part of the problem is worth 1 mark, which makes it 2 marks in total. Always read the question carefully and then proceed to answer. So for part 1, you need to recall that Grignard's reagent cannot be prepared in the presence of water because it reacts with water to form hydrocarbons. So you shall write that Grignard reagent reacts with water and gets decomposed. So it is produced in anhydrous conditions. Coming to the next part, which is a difficult one. For this, you need to know the structure of neopentyl bromide as well as apply the knowledge of SN1 and SN2 mechanisms. Neopentyl bromide is a primary alkyl halide. Thus, it reacts slowly through SN1 mechanism. Also, being a sterically hindered alkyl halide, it reacts slowly even through SN2 mechanism.
HOTS questions are not out of the world. They just involve a slightly higher level of application. So keep your cool and be careful while reading the question, and you'll see that everything is getting simpler. So here the question and answer session is over for the day. But for more problems, you can always log on to our website, and that's www.topperlearning.com, and get an in-depth and highly comprehensive list of what all to study for your exams. Now it's almost time for me to go, but before I leave, here are some priceless tips that'll make you be a topper.
Mainly conceptual questions are asked from these chapters. So reasoning questions based on various properties are generally put up. You should practice questions based on acidity of alcohols and phenols as they are important from exam point of view. Also pay special emphasis on the mechanisms of the various reactions, especially SN1 and SN2 mechanism in the chapter Haloalkanes and Haloarenes, and dehydration of alcohols in the chapter Alcohols, Phenols and Ethers. Then do remember to practice questions based on various conversions. And learn all the named reactions well, as sometimes short notes based on named reactions are asked in the exams.
That's all for today's episode. Apart from this, always remember to hold your head high and be confident, because you have everything: preparation, practice and topper. Hey, you lack nothing, and that's great. So nobody can stop you from getting that high score that you deeply desire. So till we meet next time, study smart and stay healthy.